Example 6. After 2 years, 3 months of $357.93 monthly car payments of a 4-year loan of 5.1%, Mackenzie wants to get rid of her gas guzzler car and get a hybrid car. What amount will pay off her car loan? All right. So what's going on here is that Mackenzie has this gas guzzler car. Okay. She has not paid off the car yet. Okay. She made a 4-year loan for this car. We don't know the exact purchase price of the car. I'm going to put that down here. We don't know specifically what that was, but that's okay here. And we'll see that in a minute that you don't exactly need that information. Okay. But so she made this 4-year car loan. She's been making these monthly payments for 2 years and 3 months, and now she wants to get a new car that's more practical. And so she has to pay off her car loan. Okay, she still owes money on the car. So she's got to settle her debt with her loan company. So what we're trying to do is figure, the last sentence here says what amount will pay off her car loan. What we're trying to do is we're trying to figure out how much she still owes against the purchase price. Okay. And again, even though we don't know what the purchase price of the car was, okay, we can still do this problem, okay, because we know the monthly payment. Okay. All right. So this is an unpaid balance problem. Okay. So, Mackenzie's been making payments for 2 years and 3 months. Okay. The full loan was 4 years. Okay. But now she's trying to pay off the loan early, essentially. Okay. So that entails an unpaid balance problem. Okay. All right. So for unpaid balance, okay, remember what you have to do. Okay. You have to use the present value of an annuity formula. So I'm going to go ahead and write that down. Okay. Why? Why do you have to do it this way? Again, because if you're paying off a loan early, okay, you won't be paying any future interest. Okay. So Mackenzie still had 1 year and 9 months left to go on the loan. Okay. So we have to, calculate how much she still owes against the purchase price of the car. We have to take it, um, she's not going to be paying any future interest. Okay. She would have been making, paying interest over that additional 1 year and 9 months, but that's not going to happen now. So we have to account for that. So that's why we have to use the present value of an annuity formula. Okay. So with unpaid balance, that's the formula you use. You're always looking for the present value when you're doing unpaid balance. Okay. P is the amount of the regular payment that has been made. Okay. That's $357.93 here. Okay. The unpaid balance has been earning interest at 5.1%. So that's going to be 0.051. Okay. Everything is done monthly here. She's made monthly payments. Okay. The interest has been compounded monthly. Okay. The key for unpaid balance is using remaining time on the loan. That's very, very important. Okay. So we need to go out and figure out how much time is remaining. Okay. So when we look at this, okay, again, it was a 4-year loan. She's made payments for 2 years and 3 months. Okay. So I'm actually going to go up here. Okay. And write this down. Okay. So remaining time. She started with a 4-year loan. Okay. We have to subtract out the 2 years, 3 months. Okay. So let's go ahead and do this. So if I'm looking at 4 years, okay, how many months is that? That's 4 times 12. That's 48 months. Okay. And then if I'm looking at 2 years and 3 months, okay, let's do the 2 years first. Okay. So 2 years would be 2 times 12. That's 24. Okay. And then we want to add the 3 months. Okay. So that would be 27 months. Okay. So we have to subtract these two things out. Okay. So the 4 years are 48 months minus 2 years, 3 months. 2 years, 3 months is 27 months. Okay. If you subtract that, 48 minus 27 is going to be 21 months remaining. Okay. When you Input time is a variable. It has to be a yearly amount. So you need to convert 21 months to years. Okay. So you need to take the 21 and divide it by 12. Okay. That is the remaining time. Okay. All right. So now we're going to put all of this into the formula. Okay. So we're going to have $357.93 times 1 minus parentheses 1 plus the R value divided by m raised to the negative m times t, okay? And then everything is divided by r over m, okay? So that's how you would set this one up. And now we just need to plug this into the calculator, and this is going to give us how much Mackenzie still owes against the purchase price, okay? Again, doing it in this manner, okay? This is, calculating how much she still owes against the purchase price, okay? Doing this neglects the interest that would have been paid over the remaining 1 year and 9 months. Okay, so let's go ahead and put this in the calculator. All right, so if we do that, we're going to start inside the brackets in the numerator. So we're going to have 1 minus, open parentheses, 1 plus 0.051 divided by 12, close parentheses, raise this to the negative 12 times, and I'll put in parentheses just to be safe, 21 over 12. Close the parentheses on time, close the parentheses on the exponent. Okay, there's the numerator. Okay, we needed to divide by the entire denominator. So I'm going to hit the division key, open parentheses, put R over M, make sure R over M is in parentheses. That gives me the quantity in brackets. And now I can multiply by the monthly car payment, which is $357.93. Okay, this is going to give me how much Mackenzie still owes on her car. Okay, so this is going to be a dollars and cents amount, so we're going to have to round to the nearest cent. Okay, so let's go write this down. Okay, so $7,176 and some change. All right, so if we round this, there are 29 cents. There's a 6 that comes after, so we need to bump it up. So Mackenzie still owes $7,176.30 on her car. Okay, so that's how much, if she settled with her loan company, this is how much she needs to pay them to pay off the loan. Okay, again, this is the amount that is still owed against the purchase price, whatever that may have been.